Well, we got a treat especial today, boys and girls. Here are notes. This is written on the back of Bob's Tire Company. Bob's Tire Company paper. That's what we call cardstock. Hello, my name is Mr. S. He sent me 3 amplifiers. Black Messenger M4V, 1 drive and 8. I want to make the I want the 4V fixed. Maybe you can make it better, stronger. You can put longer wires on it. Or I could send cash. Okay. 4-pill Fat Boy HD. It's this guy. The only difference is it's in a big cabinet. 4-pill Fat Boy HD. I don't know if it's worth fixing. If not, you can have it for parts. I was driving it with 40 watts. All right. The 3-pill Fat Boy. Fix the 3-pill if it's worth it. 3 times I had it fixed. You can only put 4 watts, 14 PEP. Maybe you can make it stronger or better. Do the 3-pill if there's any money left. Now, what he discusses is his budget is $400. Okay. Let's start here. Come here. Oh, hey, no, come on. Somebody out there in YouTube garglers now going to be down in the doobly-doo below going, he's so abusive. Do you see that? He almost ripped the wire out of that fan. It's okay. I work at the place where we get the parts that make this shit work. I can fix it if I break it. Pretty sure. Let's go look at this. Oh boy. Ready? Here we go. He said this has been pot a couple times and it needs help. It's tied. Well, we know for a fact that we've got blown an SRF 3749, which is a great part. At least it was back when. This one. And we can tell because the little 10 ohmer is now let the El Smoke out. You're all familiar with the Frenchman El Smoke? Yeah. El Smoke been here and gone. Magic electronic smoke come out the holes. No more El Smoke smoke. Okay, enough of that shit. These transistors looked like they were soldered in by a chicken. This is what we call chicken poo. See a couple of things in here I want to change, but we have to ask ourselves why the pills keep popping. And then I look at this resistor, and I look at that resistor, and I think, okay. Let's let that field of knowledge slowly sink in. And know that we've got a blown pill, so this thing is definitely dead. Now, Mr. S, this is a low drive amplifier. This is 1 drive and 2, so there's technically 2 amplifiers in that box. And yes, it's going to be an incredibly low drive amplifier. If you want it to be a little bit higher drive, what we do is we bypass that 1 pill section. Now, I've called him at least, well, he called me twice today, and he tried to get me to find these last week, and I was just too busy. I couldn't stop what I was doing. When you guys randomly call me and say, where am I at? What am I doing? Blah, 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 I have to stop everything I'm doing, and then I got to go dig. Once again, let me reiterate this to everybody, and I appreciate everybody's patience, and please don't think that I'm bitching, because I am absolutely not doing that. It does make it a little bit of a hassle unless your stuff is right up top. September, not of this last year, but the year before that, so like a year and 3 months ago, I went out there after like 18 months of telling people that I wanted to make it so that I could take on new work and that I was ready to take on new work. So on September 1, I didn't publicly go out and say it. I hadn't had the chance yet. I'd formed the YouTube video and had it all loaded up in the system. But I launched okay, I'm ready. It's now September 1. By September 20-ish, I was out there crying, saying, stop, I'm completely overloaded. And what had happened is I got myself worked down to about 30 amplifiers, which was odd because I have enough shelving here to hold about 300. 300 is about the max that I can work on per year. Per year. Well, Mr. S here was one of the guys that listened to everything I said on the internet, and I'm not giving him a hard time for it, and I'm telling him thank you, and that we love him, and that we appreciate him, and that we're grateful for him, and that please don't take this as like I'm saying something negative, and I'm not. And I'm not trying to brag or anything. I'm just saying this is what happened. These are the facts. This is what went down. This isn't an opinion. This is what happened. On September 1, I got like 5 or 7 amplifiers on September 1. This is before I went out and said publicly send them. By the 20th of that month, I'd received almost 800 plus pieces of equipment in like 15 or 18 days. And I was scared because it was to the point where I couldn't get in and out of my shop. Everything was stacked on top of everything else, and I was more freaked out that stuff was going to get damaged. Well, Mr. S's equipment here was one of the first things here, but it ended up getting buried at the back and at the bottom of things, which is kind of screwed up. That's the way it was. So he called me up, and he, with a desperate plea of animation in his heart and in his mind, and he shared with me, hey, can you please look at my 3 amps and tell me where we stand? And I'm like, yes. Well, it took me to where I had enough time today, and this took most of my evening, like 3 hours, to find all 3 of these amps. They all came in together, but they got put in 3 different spots, and they were buried in the back and behind everything. So I found this one and this one right out the way, and then I thought this one here was one of his because it had a label that had fallen on it. And this is a 6-pill. It's also full of Toshibas. I don't know who this belongs to. There's no information with this box. So next week I will travel down the path of trying to locate its owner. That's not for today. Today's Friday night. It's midnight, so it's technically Saturday early morning. And I want to get started on this because I'm going to work on all of these and get them finished tomorrow. Then I have my one day off that I have a week, which is Sunday, and then I got to come back Monday and I got a masterclass build that I got to do. So we're going to squeeze him in on my time, which is Saturday through Sunday. I am closed on Saturday. I am hard closed on Sunday. If that makes any sense. Long story short, he tells me, he goes, it's been so long since I've seen this amplifier. You know, he text him pictures back and forth and the whole 9 yards. We established that 6-pill's not his. He goes, no, I'm pretty sure that what I sent up to you was like a 1 drive and 8, if I remember correctly. He'd had this for like a couple weeks and he sent it up here. We don't know if it's working or not. According to the note that he sent up here, it's not working. That's obviously not working. So is that not working. So I go digging. Now, the way my shelving units are set up is I set them intentionally high enough for me to put like a Henry desktop 2K84 or an SP220 up on its side for the shelves. Okay. For some reason, this amplifier was on top of 2 SP220s, and it was underneath the lip that's about this high underneath the shelf. It was up underneath that, and on the bottom shelf and in the back. I had to go dig in. I got on my spelunking light. I'm not kidding, where did I put it? Here it is. The shelves all got lights on them and everything, but I had to get on my spelunking light, and I'm down like blade down the crevasse in the hole. In the hole. And I seen this thing sitting in there, and he told me, he goes, it's all black. It's only about 8 inches wide. It's about 8 inches long, and it's about 3 inches tall. And it says amp 65 on the front of it. Don't ask me, I don't know. It is what it is. That's what the inside of the tin says. So I found the thing and slid it out, and his name was right on the top on a piece of paper. My wife did great due diligence, and it was, I'm like, sweet. So we locate all three, and now it's time for us to start talking about if we want to, you know, what we want to do. I mean, really what we want to do here. So I go to looking at this messenger. First off, this is a really cool messenger. This is what one of the first generation messengers looked like. Look at the heat sink fin pattern. It's way different than, here, let me go get its modern equivalent, or what was its modern equivalent in the 90s, 20 years after this box was built. I'm gonna grab this guy's absolutely beautiful gem example of a messenger. These guys here are coming up pretty quick too. You see the difference? The same principles are here. Internally, the boards are laid out very, very closely. The components have changed. This probably had Toshiba's in it. This one's got SD 1461s in it. This one here. This one's got a fan kit on it, variable speed fan kit. I'll show you all this stuff later. This is going to be in its own video. These don't even have any scratches on them. They got some dust, and that's it. And that's from sitting up here. Because unfortunately, right across the way from where all these things sit is my lathe, my mill, my sander, my drill press, and my welder. So there's a little bit of dust down that side of the room. But I digress back to here. There's some radical differences here as far as the component layout. The bias circuit is controlled by this load resistor that they smartly strap across the top of the transistor. It would have been better if they had a little bit of thermal compound on that. As the transistor heats up and the amplifier comes into operation, you want the temperature of the diode that controls the circuit to change as well. That way the current flow for the bias can stay linear with the operation and the heat curve of the component that you're trying to control. It's the same thing that's going on here. This is the load resistor. This is the diode for the bias circuit. And here's our choke for our input. Completely differently done modernly. The same thing here, that diode resistor, or diode here, here's our load resistor for all of these 8 transistors. Choke, 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 and choke. And that's how we achieve the class B bias operation, not AB1. Unless we're trying to run these in FM, which until recently FM hasn't even been a legal form of operation on 11 meters, but it is now. Then you can achieve the state AB1 stably in a push-pull bipolar transistor configuration. Blah, 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 blah. It's Class B. Big fancy words is Class B. So, this thing was checked November 19th, 1980. So I'm assuming this is a born-on birth date. They don't do this anymore. They didn't in the 90s when they finished up their last runs of builds. And if you guys had any idea how many amplifiers are built in this same theory and forum and built off the same design. The 7-to-1 combiners, the way this is set up, the capacitance loading on the circuits. I mean, people copy what they see, right? It's easy to copy this circuit. I mean, the guys with the Dremels, the Dremel Kings from the 80s and the 90s, they copied this exact same circuit. The major differences is this diode here and this diode here. There's notches cut in the board where the diode drops in, and then they put thermal paste, and then they put the diode up against the heatsink, which is a much better way to control it. The other way to do it is to take the diode, like I like to do it, for simplicity of building. I mean, I could make the thing a little bit more complex if I wanted to, but I take the diode and I put it right up against the sandstone resistors, whatever people call them. It's a wire wound ceramic coated resistor. I put it right up against the resistor, and then let the heat that comes off the resistor wick over and change the leak structure of the diode through direct contact with the load resistor, and it works out to be almost the same linear curve. This amplifier looks really good on the inside until you start looking at the details. What do you mean by? Let's take a look here. Okay, let's back this down. Back this up. The details. This 100 ohm is smoked, that one's smoked, that one's smoked, that one's smoked, this has been changed, this one's been changed and broken. This has been changed and this has been changed. I have a feeling, just basing off looking at the work, that the same technician that worked on chicken poop here is the same technician that worked on this amplifier, and I guarantee you it's the same technician that worked on this amplifier. We can tell because of the solder skill rate, how things are put together, and also the type of resistors that are inside the device. We're going to see a whole lot more of these in the coming future. So I feel relatively safe, even though that there's this hackma job here of power wires. Yes, we're going to replace these. I feel relatively safe. We're going to put power to these, and we're going to test this at a very low power input level, and I want to see how many of these heat up. There's no one on earth that has these new old stock that I'm aware of. I mean, there might be some dude that's sitting out there with a warehouse full of these and doesn't realize he's got a gold mine of components sitting there, or maybe he does. And he'll be dead and his kids are going to throw him in the trash probably. Anyhow, I digress. I want to see how well these turn on and see what kind of problems we have. This is really common, these burning up. Hence the reason they went from the 1 watts that these are, or maybe 2 watt, to the 2.5 to 3 watt resistors that are in the newer 90s version. These don't do a lot unless you seriously overdrive them, or for some reason the amplifier falls way out of tune. Like this, somebody starts screwing with this Arco and they don't understand how to set it up, and the amp falls into a state of oscillation. I don't know, I don't see any signs of heat scoring on this or anything. I just see a little bit of dirt and bad part replacement. So like we'll come in and we'll reattach this flyback resistor even though it's not hypercritical to it working. That's amazing to me that even in the 90s, in the 80s I mean, the guys that put together the messengers recognized that they had a lack of ground structure. I mean, they had screw, screw, and screw, go into the case, trying to get the case to bring up the ground potential, and the little traces carrying ground in between wasn't enough, and they could see that in their tests, and they were still trying to figure out how to get more ground to the system, only to see it later on down the road replaced with a piece of phenolic that sits over the top. It looks like copper strip or tape, but it's not. It's actually a very thin piece of phenolic that goes over the top of these. In the 90s versions, that is. The attenuator circuit's slightly different. Yeah, I can see why they went to a mounted board on the back of the high, medium, and low switch. This is usually the first thing to get effed off. I mean, like completely effed off. These resistors melt down to like Chernobyl level 3 Mile Island meltdown. I mean, imagine having to hand bend. I don't have to imagine, I do this all the time, but imagine hand bending all of these to put this entire circuit together. They ended up changing the traces over here a little bit and mounting everything to a board. Yeah. Other major difference is this. In the 80s, this was a really, really common form of relay, this flat pack relay. This relay moves like this instead of, it moves this way. A really quite solid, stable relay, but they quit making these in the 80s. And I can see why they switched. We'll come back to this. All right, last amp. If the pills aren't screwed off in this thing, I'm pretty sure we're going to be able to get this running again, by the way. So, last amp. And you're going to see what I mean by the common thread in the components. By the way, this is never a good thing. And the grommet being half effed off and then zip tying it to the vent, never a good thing, by the way. This is what they consider to be a comp box. It's got the exact same heatsink in it as a standard 2x4 cabinet. Same length, heatsink runs from here to here. Only difference is wider, the cabinet's taller, and the idea was that you'd be able to put a high flow fan in it. That high flow fan has been there and gone, Bubba. Look at that. This amplifier has been wet. It has been submerged to at least here. You can see the scum line of where this thing sat underwater at some point. The pill screws, which should be stainless, obviously were not. This has got Toshibas in it, but let's slow down and let's look at the bigger picture. What do we have going on here? What's going on here? Okay, now let's really slow down and let's look at the bigger picture. Let's look here. Let's look here. And the same thing's going on up here. To me, it looks like the resistors popped. Oh, and this is matched. These two are matched the same lot. This is a red dot, and then this is a different lot number, and this has been resoldered, but somebody that actually knew how to use a soldering iron, not this feeble attempt at getting stuff to stick together. I like this. This is cool. Dangerous as frig, but this is cool. So we're going to power this one up. I guarantee you this one's going to have some blown pills in it, if not all of them. So we'll power this up and we're going to check it. First we're going to start by the 1x2 because he really wants to get these two fixed. So let's do a damage assessment on this one. Well, I'm not even going to do a damage assessment. We're going to pull out the two final stage transistors, reflow the 1446 driver, check a couple little parts in this and we'll get the 1x2 working. This one here, we're going to hook it up and assess it and see where we're at with transistors, and I got to call the customer. This thing here, I think the heat sink is the most valuable thing in here. I have a very strong feeling that the pills in this thing are junk. But we'll find out. We'll determine all that together. You, me. That resistor's popped. This one has been replaced. And when they replaced them, you can literally see where they cut. Hopefully I can zoom in close enough you guys can see it. You see the old leg of the resistor where they just cut it and then they slobbered another one on top of it? You don't be that. And don't leave enough shmoo to where you've got it literally arcing over. And what I mean by is solder shmoo. This amp was never built with these transistors in it. I can guarantee you that. This was a 2879 box at some point, or it had PP something or others in it, or whatever the hell. It's gonna have HGs in it because these SRF 3749s are really hard to find, and I have a very strong feeling that they are way blown. Way blown. But the number one thing that causes these to fail is these caps here. They'll get hot. One of them will fall out of tolerance, and instead of this being 1,000 puff, it'll fall off and you'll get like 450 puff up here, and it makes the amp fall way off in power, and then eventually the thing just, because the circuit's no longer in tune to the component fails. So we're going to fish these out, clean the pill pockets out real good. I bet you that we find shit underneath the transistors. You know, the usual scumbag suspects. Well, I got a guy as a technician. He'll take care of it for me. And the guy goes in there and does a shit job, and the thing comes apart. It is what it is. This is part of life. God, every time I look at this, I find more solder flick that. More solder flick that shouldn't be in anything. So, okay, I'm going to rip this apart and we'll be back. So that's not too bad. Maybe the output tuning cap is what devaluated and is causing this thing to blow up so much. Either that or we're going to have to go with the spin over driven a lot. Okay, so we got this all stripped down. Got all the chicken poop sucked out of here, reflowed the pill strips. This pill strip's pretty cratered, but the main thing when you guys go to change a transistor is to get the heat sink clean. I mean, just take a little bit of rubbing alcohol and flush this whole area, and take like a paintbrush and get in there and get all the old thermal compound out. You know what? Let's grab the transistor checker here real quick. Not the most accurate thing in the universe, but close enough for the home gamer, and that's why I like using it, because it's easy and doesn't require a lot of setup, and it's not a giant machine. Our Atlas DCA 75 Pro, which is better than 99% of all other transistor checkers on the market. This has got an HFE gain of 7. And the survey says junk. Okay, so this one is good, has a gain of 7. This one here is a diode junction. Translation, garbage. So set this one aside. Get out the old L Sharp A. Put a little marquee mark on it. We got prepped up for ourselves over here, 2 HG 16D08s, which will outperform these transistors by a mile and a yard. So let's put these in here, put some new 10 ohmers in it. We'll build up new flybacks for it. What do we have here? A little ball of fuzzy. That's it. Okay. Yeah, we'll get this put back together. We reflowed the joint around the driver transistor, and it'll power it up, and we'll check the output capacitance here in just a minute. So, man, it feels good to be doing a repair again. I feel like this is my goal in life, is to be able to do these. And I felt so bad as I'm moving all these amps today. I'm reading the names and all the information on them, and I'm going, God. I swear I'm taking all next month and I'm doing nothing but repairs. Period. I swear to God. God, even the LED is broken. Jeez. Okay, so we're back. New 10 ohmers. There we go. That should fix. Up, did. Cool. New 10 ohmers, new flybacks, new transistors, clean the pill pockets out, fix the LED on the front of it. Okay, so let's go around and let's look at some units and measure here. Make this a little bit brighter so you guys can see what the hell's going on. 1,000 watt slug and peak, 1,000 in average. Currently 5 watt slug in reverse. Let's turn this around. So now it's reading forward. Let's turn this down to 1 watt. We're currently on 12 volts on the bench. So 1 watt going in. Turn the amp on, variables all the way open. Makes about 30 watt carrier. Hello. Oh yeah, it's gonna run good. Hello, 11111. Hello, 1111. Hello, 11. So let's go up here. Input tune is hello 11111111. Totally acceptable. Hello. For my side of the street, it's looking like almost 400 watts, 380 watts. And remember, it's on 12 volts. Let's turn on a bench power supply. Let's let this slowly leak up. 14. Hello. Oh yeah, 510. Take a look at it now. Hello. So this big hash mark here is 500, so that's 4, that's 6. We're reading the bottom scale, adding a 0. So 400, 600. The big hash mark is 5. Hello, audio 1 2 1 2 1 2. Let's change our perspective on things. Hello, hello. For you needle watchers out there, that's 200 bird and 510 peak. Out of a 1 driving 2. Amazing. You take an MRF 454 HG, 2 of them, put them in here, get rid of this whole driver's section at 30 watt radio, makes 400 watts. Saying it's like, interesting. And it runs like 40% cooler than these parts ever dreamed they could. So more efficient, pulls a little bit less current. Okay, let's see. Turn amp off. Let's see what we got. Can we talk through the box? Hello, 1 1 1 1 1 1 1 1 1. Let's go up here and look at the pass-through SWR. Hello, 1 1 1 1 1 1 1. Good. Okay, so Fat Boy 2 pill. Hello, 1 1 1 1 1 1. Hello, 1 1 1 1. Hello, 1 1 1. Hello, 1 1 1 1. I think I'm going to take this and just walk away. Hello, and that's with a 1 watt carrier. So, last thing we got to check is for smoothness on the knob. Hello, it's all the way down on the variable. Hello, and it's all the way up. All the way up. Dead key. All the way down, dead key. 1 watt going in. Yep, this thing's good. I call it a win. Shut-up! Okay. Whew. I'm going to put the tins on this thing, put the screws back in it, and let's go on and take a look at the Messenger. Okay, so the preamp is blown out of this thing. We're going to put this thing up in high. And these being the wrong, these last 4 being the wrong value resistors for this situation, we're not going to see anything from them. So we're just going to look down at our transistors and make sure they're all working. I can almost bet you anything it's this tuner in the back. So let's make it a little bit of power. Oh, Mr. S, you got lucky, you duck plucker. Take that picture. All your transistors are working. You got lucky. Okay, let's see what we got going on here. Let's do this. Hello. Oh, yeah. You can hear it arcing. Hello. Yep. Hello. It's so bad it's making the computer think something's plugging in and unplugging from it. Let's go ahead and let's turn on the old spectrum analyzer here. I see my future ahead of me. I'm just going to be ripping this tuner out and replacing it, and replacing all of these resistors. Oh, that tuner's screaming hot. Ambient air is 58. The tuner's 80 degrees. Hello. Oh, God. Here, look at this. Hello. Yeah, no. Okay. So, you're in luck. Everything's working, as far as the pills are working. It's a huge worry off me, man. I was a little concerned that you'd have a pop pill or two, because these things are impossible to find. Now, let's fix this. That can't be good, right? Let's fix that and see if we can get it to run a little bit more smoothly. Okay, take 3 on this segment. Oh man, I just shot the most beautiful segment ever. It was a necropsy of this capacitor. I took and I pitched all the parts in the trash, and the only things I can find are these 2 pieces right here. I'm gonna edit those hunks of video in here right now. Okay, so how a capacitor works, at least this one, has only got 3 plates. And what it is you have 2 pieces of conductive material and then an insulator that sits in between. So you're going to have an insulator, or a conductive piece of material, an insulator, then another piece of conductive material, and then an insulator, and another piece of conductive material. And as you sandwich them together with a screw or a nut or a bolt and change the pressure, that's how we vary our capacitance. As we can clearly see, we've got ourselves an arc where it is burned through. Otherwise, the amount of RF has exceeded the dielectric principles or properties, has exceeded its ability to insulate itself, and it's arcing through. This is the biggest Achilles heel for that cap. Okay, let's come back over here. This is the biggest Achilles heel for this amplifier, or these caps, these variables. I don't care what kind of glue, paint, fingernail polish, Loctite, jism, whatever you put on this little cap, it'll inevitably vibrate itself loose, inevitably, in real-time use. But of course, you got to remember, this is a 40-year-old piece of equipment. It's 2022, boys and girls, and this thing was made in 1980, 40 years ago. Okay. So what we're going to do now is I'm going to take a air variable capacitor. Looks something like that. I'm going to bolt it to the cabinet. We're going to hook it up here and we're going to tune it out for this particular amp. And then we're going to replace this with a fixed value capacitor so this never happens again. These caps either get hot and they break down and they blow up, like what we've seen here, or they jiggle themselves around, or the Seabeer does it to himself. The Seabeer does it to himself. The problem is anything that's got a slot on it, it's a screw, the driver of the screw, and you leave it up to the Seabeer. And man, I bet you the guys that put this together didn't know what the hell they were doing. And if I just get over here and I adjust this, I'll make it do 10 gigawatts. And they get to the screwbin of the screwdriver. Never turns out well, because once they break, they're like, oh, well, this is just a, you know, what Messenger ended up doing is they put paint on the screws, and people thought, well, that was so they could tell if you're tampering with it or not. No, that was to keep it so it wouldn't change value. So as soon as you go in there and make that adjustment, unless you repaint that cap, it's going to fall out of adjustment, because the vibration alone will cause that cap to back out and change capacitance value. So let's retune this. Let's put a fixed cap here, and then we're going to go work on the rest of the problems, like power wire and all that kind of BS. Little 100 puff metal mylar added, which will never break down. Okay, so we're heading in the right direction now. So, hello, put about 20 watts in it. Hello, 400. So now it's an M4V. Okay, makes 400 watts. That's for the power at 12 volts, 400 watts. So, now to do the fun bit. We're going to go in, we're going to replace these with all 2-watt resistors, because there's no reason to really put 5 watts in here. That'll help it dissipate. We're going to put the right value of resistors in here. That's going to help a bunch too. There's a little bit of heating over here from an imbalance from this 4-pill section. Gee, I wonder why it's got the wrong resistors. Change that out, fix the preamp in it. We're going to upgrade his power wires, and we're out of here. So, wink, let's get her done. Okay, well, okay, power wire is done. All the new resistors are put in. Everything is set up. Gave it a quick bath. Let's see here. Let's turn this on. Preamp is fixed. So, oh, there goes the 21. Hold on. Let's see if we can go 5 minutes without getting interrupted, you guys. What do you think? Sound like a plan to you? Sounds like a plan to me. All right, so everything on here works now. 100% fixed. Let's go back over here and take a quick look at this. So, show drive, amp off. Hello, 1 2 1 2 1 2. Okay. Turn the amp on. We've got the amp in high. Hello, audio 1 2 1 2 1 2 1 2 1 2. Beautiful, right? Oh, now look. Silly me, because I spent the last 2 hours totally dinking around on the phone. I turned off my spectrum analyzer. It's actually quite clean now. But everything on here works. It blew out the receiving transistor for some reason. Power wire's done. We did a little bit of a ground upgrade here. Don't touch these. Oh, pardon me. Don't touch these. This tuner here and this tuner here should never be adjusted ever again. So, needless to say, hello, 1 2 1 2. Let's go up here and we'll look at your input tune here real quick. Hello, 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 hello. Beautiful, Mr. S. It's looking really good. And let's come over here and let's look at the spectrum. Way cleaner. The second, we were able to get rid of the, almost completely eliminate the second, the third, and the fourth order harmonic. The third and the fourth order are completely gone. 1 1 1 1 1 1 1 1 1 1 1. That's a beautiful thing. Squeaky, snotball clean now. So, Mr. S, this thing has regained its glory spot. Like I said, 1 watt carrier, swing into 30, leave that on high. And this will last you from now until the end of time. Okay, I also added thermal compound to the bias diodes, so that'll allow us to have just a little bit more linear operation, but not that much really. See a little white chichism here, and the white chichism there. So, gave it a bath also, got it all cleaned up. So, this 1980s version of this messenger is done and done. And this thing is a rare article species. I took pictures of this and sent this on through another friend of mine to the guy that co-founded Messenger. And no, it's not the guy down there in the desert in Nevada. This is the literal real deal guy that started Messenger. He thought this was neat. He's like, oh my God, I can't believe that's still in existence. He goes, is it a late 90s model? I'm like, no, it's a early 80s. He's like, oh my God. So, okay, I'm going to throw the tin on this thing, and we're going to consider this done. Let's go quickly look at your 4-pill, which I'm pretty sure half the transistors in it are blown. I wish I could explain to you everything that was going on in the background right now between the phone and PayPal and their virtual terminal issues. They're having not your all's problem, that's mine. I have been standing in the same spot since 11:30 this morning, trying to get the last 2 segments of this video shot. It's just the phone. So we're down to the tail end of this deal. Now, me personally, I know what this guy's budget is, and we're going to spend more money repairing this than what his budget is. So I'm pretty sure we're going to have to call no joy on it. But I've had to bypass the key-in circuit in here is borked, okay? So how we got to run the relay right now, because I got the jumper in it, is with the on-off switch. So let's go over here. We're going to put some juice in this thing. We got our voltage way down. We're on 12 volts. Hello, 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 hello. Remember, radio is supposed to be cool. Okay, so let's put the amp. We're going to turn it on. And then we're going to put a little bit of jam in it. Our whole 30 watts. Hello, 1 2 1 2 1 2 1 2. Okay, so we can clearly see that these 2 transistors are heating up and their partners are dead. This transistor here, dead. This transistor here is dead, and this one here is dead. But this one up here is getting hot. Hello, 1 2. Okay, we don't want to key that for too long. That one there and that one there. So we have 2 good transistors out of this 4-pill. These 2 are El Blone. Now, I don't want to keep voltage on this, and I don't want to key it ever again, because all we're doing is destroying those last 2 transistors. That simple. For us to bring this back to life, and for me to feel comfortable with it leaving here, we would have to wash all the the shmoo out of here. You have to wash all the dirt. That's black mud that's in the bottom of this thing. And it runs all the way to the back of the cabinet. New power wires would have to remove all of this garbage in here that doesn't need to be here, like this output tuner. This is a great idea, but this is usually what people put this in there to do, is to help compensate for a bad input tune on another box or irregular length of jumper cable or something like that. I mean, if you wanted to finely tune your output section, this would be the way you do it. But then what happens when you're driving down the road and that little fin, it slowly knocks itself down and changes its tune, then you're screwed. Okay. So we'd have to remove that. New power wires, of course, and then 4 new transistors, new resistor, new resistor, new resistor, new resistor, new resistor. Change this to a fixed value cap, and then we're done. Oh, and a fan that works, because the fan, when it got wet, did no work no more. So I'm going to call the customer. I'm sure he's going to tell me to bag this thing, because he's probably not going to want to spend the money on it. At the end of the day, the 1x2 is completely restored. The messenger is completely restored. I'm tired. Mentally, physically tired. I think I'm going to go shooting. It's 3 o'clock in the afternoon on Sunday. I think I'm going to go shoot my gun at the shooting range. Gentlemen, you guys have a great rest of your weekend, or a good week, or whatever time of the week it is that you decide that you're going to get to watch this thing. I want to say thank you. I appreciate everybody's support. I want to give a big shout out to my Patreons. The list is coming up next. Without them, I wouldn't be able to be here, but like I said, it's Saturday. I'm closed. It's technically my day off, but I wanted to give a little bit of love to this guy. Next week is a Joker amplifier that we're going to pull the pills out of it, and we're going to rebuild a Texas Star. So, on that note, you got a question or anything I can do to help you? It's like the A-Team. Call us. We'll get you square. Gentlemen, I want to thank you all for watching once again. Thanks to Siglet, MechMan, Excess Power, Bird, Coaxial Dynamics. I'll see ya. Click, click, click.